Hello, this is the second video for REMS 5953 of week 1. First, I'm going to share my screen video. Hold on a second. Yep. Here is our presentation for video 2. Yep. So in this lecture, we're going to talk about the frequency distributions. So this is the outline for the second video. So we're gonna learn about the frequency distributions, including frequency table and histogram. And also we're gonna talk about the shapes of the distribution, including normal distribution and skewness. So let's just start. First, I would like to talk about data and how gather data and what it looks like. So we talk more about this when we introduce SPSS, but for now, let's just talk about simple spreadsheets that you can see. So the data are collected and stored in a spreadsheet. Sorry. Spreadsheet. And it looks like this. So in the spreadsheet, each row represents a different subject or a case. So based on the table in the right side here, we have 1, 2, 3, 4, and 5 subject or cases, right? And each column represents a different variable. So here we have 2 different variable, gender and age. So for the first subject, we can see gender as 2, age as 25. And for the third subject, the gender equal 1 and age equal 30. For non-numerical data, like for a categorical variable like gender, we often code our spreadsheet. And it is important how we code them. So this is the way to represent our categorical variables. Male equal 1, female equal 2. Yep, this is totally up to you. So you can just simply code as male equal 0, female equal 1. Yeah, whatever, that's fine. It's up to you. But you have to fixed number for all males and all females. That's it. So back to our table. The first person is female, and age is 25. And the fourth person or subject is male, and age is 27. So we can take this spreadsheet and summarize using frequencies and descriptive statistics. So let's talk about the frequency table. A frequency table organizes discrete data indicating the frequency or how often each value occurs. So here on the bottom is our frequency table for the variable gender. So in the discrete variable, each value is listed in one column. So here my level of gender is male and female. And the number of individuals with that value is in the second column here, the frequency. Actually, this is the number of our level of gender. So in our data spreadsheet, how many males in here? Yeah, 1, 2, and 3. So The cell for the frequency equal 3. And how many females in our data? Those two. Yeah, so we have 2 females. Yeah, so this is the frequency table for the gender variable. So like the categorical data can be displayed with a bar chart. Now you may think that it looks like the histogram. Actually, it's quite the same, but I will talk about the histogram after a while. For now, we stick with the bar chart for a categorical variable. On the x-axis here, we can see the different level of our variable gender. So male and female. And male had frequency of 3 based on our frequency table. So here is the 3. And female had 2 frequency, right? So the height of the female bar equal 2. Yeah, this is the bar chart. So in the bar chart, x-axis represent values of the variable or levels of the variable, and y-axis represent the frequency of observations within each value or each levels. And for the categorical data, the bars on the bar chart do not touch. Yeah, here is a space between the first bar and the second bar, right? Here is the distance and space. This is the difference between bar chart and histogram. I'm going to explain again about this difference in the histogram explanation. The next one is group frequency table. Group frequency table is for the continuous data indicating how often each range of values occurs. Yep, the difference is here range. So our gender was categorical, and for that we used bar chart based on the frequency table, right? But our age is the continuous variable, and gender was categorical variable. Yep, since our age variable is the continuous variable, so for that we are going to use group frequency table. Actually, this age data is not too bad, but if we make a bar chart with age variable, maybe the x-axis will have a lot values, right? From 22 to 30, like this, 22 and 23, 24, like this. And we have only 122, 124, and 125, 127, and 130, right? But that's not helpful for us. Especially think of the variable with wide range like income. We do not want that x-axis have all the values of the incomes, right? So we grouped our variable into smaller equal interval range. Here, equal interval ranges. And there is a different rule of the equal interval, but it's totally up to you. You can just choose. So I've taken age variable here and I've broken it up into 4 subgroups. 20 to 22, 23 to 25, 26 to 28, 29 to 31. Now it's important that each of these have equal intervals. So in this example, the range equal 2, right? This it can be a confused, so yeah. Range equal 2, right? Everything was the same. Yeah, so the range equal 2 and covered 3 different ages for each. 20, 21, 22 in the first subgroup, and in the second subgroup, 23, 24, 25, something like that. And the frequency is the number of observations within each of range. So the frequency within each of the range is 1, 2, 1, 1, right? Actually, between 20 to 20 to 22, we have only 1, right? This is the first subgroup. And between 23 to 25, we have 2, right? I'm gonna just change the color. Yep, 24 and 25 in the second subgroup. So here are 2. And between 26 and 28, there is only 1 here. This is the third subgroup. So here is only 1. And lastly, between 29 to 31, there is only 1 subject. This is the fourth subgroup, and here is 1. Yeah, this is the way how to make the grouped frequency table based on the continuous variable. So let's talk about the histogram now. For continuous data or numerical data, we can use a histogram. Actually, it looks like a bar chart since it's made up of many bars right here. However, notice that now they are touching and there is no space between bars, right? There is no space between each bars. This is the biggest difference from bar chart here. Do touch. And on the x-axis, we have age, but instead of each individual age, we have midpoint of the different groups. So the midpoint of 20 to 22 as 21, right? And the midpoint of 23 to 25 as 24. Like this, first we can find the midpoint for each range and use those midpoint in the x-axis. So on the x-axis, the midpoint of the range of values were used. And then each bar is centered over the midpoint at the height of the frequency. Here is only 1, so here is the 1, and here is the 2, and 1, and 1. So y-axis represents the frequency of observations within the range of the value represented by the midpoint. Mhm. And the height of the each bar corresponds to the frequency within each range of data. So this is the histogram. The next one is the line graph. A line graph is similar to the histogram, except instead of bars, we just use a bunch of lines. So we might call this as frequency polygon. Mhm. Again, we have the midpoint of our grouped frequency. Actually, the line graph looks like this in the left one, but I mean, there is no bars, but for better understanding, I just bring the histogram and made a line graph on it in the right side. So we just put that on the top of the midpoint or centered over the midpoint and connect these dots. Yeah, simply just connect. That's the line graph. So in the line graph, like the histogram, x-axis represents the midpoint of the range of values, and y-axis means the frequency of observation within each range of values, and the height of each dot corresponds to the frequency within each range of data. So we covered everything for the frequency distribution. So let's talk about the shapes of distribution. Notice here that we have a histogram with a bunch of bars. And then over that, we have laid this line, right? This line. So it goes from left to the right. And this is the most of the common distribution or shape of graph we can see. So distribution is the way in which the values of a variable are dispersed across a frequency table. And this is the normal distribution. And we will talk more about this in the whole lecture on maybe in chapter 6. But now we can see some of the characteristics of the normal distributions briefly. First, it is bell-shaped. Yeah, actually it looks like a bell. And it is symmetric about the centers. So just changing colors. Maybe here is the center. So if we for the graph around the center, maybe the left and right side will match up. And this is also unimodal. Yeah, there is only one mode or value of the highest frequency here. So here we can see that it's centered with 0 and increase or decrease with equal interval. This is the normal distribution's characteristic. In addition to the normal distribution, I have a little bit different things, including skewed distribution, bimodal distribution, J-shaped, and inverted U-shaped, and rectangular or uniform distribution. Yeah, we have a lot. So first, a skewed distribution is an asymmetric unimodal distribution with one tail longer than the other. So actually the skewed distribution has a similar characteristic of the normal distribution. So it has one mode here and here, and it looks like a bell. However, one tail extends much further than the other tail in this side and this side. So if it extends into the negative direction, yep, usually the middle is 0 and this side is the positive and this side is the negative. So if it extended into the negative direction and most values are clustered around right tail of the distribution, we call it negatively skewed distribution. On the other hand, if the long tail extends into positive direction and most values are clustered around the left tail of the distribution, we call it positively skewed distributions. So you just see the tails, which tail is much longer than the others. Then you can just assign a name for the direction negatively and positively. The next one is the bimodal distribution. Actually, it has two values with the highest mode. Here, we have 2 points of the highest frequency in the distribution. So this is the bimodal distribution. And a J-shaped distribution has a continually increasing or continually decreasing slope. So here is the J-shaped. This J-shaped distribution starts at the minimum, right, and increased up to maximum, and it is usually called as ceiling effect. On the other hand, we can have a opposite side of the J-shaped distribution looks like this. Yeah. So it starts at the maximum. I'm just maximum and decrease up to minimum. And it is called floor effect. So this is also J-shaped, but opposite side of J-shaped. Opposite side of J-shaped. I also put inverted U-shaped distribution here. Sometimes we can confuse with normal distribution, but the inverted U distribution show the performance as gradually improvement reach on the optimal path and decline. This curve will be used more specific mathematical situations. And the last one is a rectangular or uniform distribution. And this distribution has same frequency for all values of the variable. All values. So for instance, if we examine the hair color for 9 different people, and 3 are brown, here is 3, and 3 are blue, and also 3 are black. Oh, wait, all 3B. This is the brown. Yeah, in this case, all values have the same frequency of 3. So the distribution looks like this, right? Yep, so this is the uniform distribution. Sorry. So here are some different kinds of the graphs, and I would like to identify for each one. So stop the video and think about what is the distribution for each graph. And then just restart the video and check with me. So let's check with me for 4 different graphs. Here is the first one. Mhm. Among different kinds of shape of distribution, which one is for the first graph? It looks like this, right? And one tail is much further than others, and the direction is negative. So this is the negatively skewed distribution, right? Skewed distribution. Yep, so this distribution is increased and decreased. Also, this distribution has a single mode here, but the left tail is much longer than right tail. So this is a negatively skewed distribution. And here is the second graph. Yep. So which distribution is for the second graph? What looks like this? Yep, it really looks like the normal distribution, right? Yep, this distribution is increased and decreased, and it really looks like a bell, so it has the bell shape. And one mode here, and it looks like a symmetry. So by the center, the right side and left side will match up. Then let's talk about the third one. How about this graph? Yeah, in this graph, the bar just are continually decreased. Looks like this, right? So this is the opposite side of J-shaped distribution with which effect? Yeah, floor effect. So this is the opposite side J-shape, opposite side of J-shaped distribution with floor effect. Or you can just simply say that this is the J-shaped distribution. Yep, that's also the correct answer. And how about the last one here? Yeah, we might think it as normal distributions looks like this, right? However, here there are a little bit different observations. So we call it as outlier. And if we ignore this outlier and just include majority of the observations, maybe it looks like a little bit positive skewed distribution, right? Positively skewed distribution. if we ignore that outlier. Maybe we have a chance to talk about outliers in the future. So you can just think about like this outlier. So are you guys answered correctly? I really hope so. So I prepare one more thing. So I would like to talk about different kinds of the examples for shapes of distribution. So I just provide different graph of the distribution. So please pause the video and write down one variable that you expect to have the following distribution: normal, positively skewed, negatively skewed, uniform, J-curve, ceiling effect, and J-curve with floor effect. Then we start the video and talk about the answer with me. Yeah, let's talk about the good example for each distribution. For the normal distribution, the general example is maybe bars or weight. Yeah, these are the general variable for the normal distribution. And think about the positively skewed. What kinds of variable that you expect? Maybe the US income. Yeah, so many rich people will be here, right? But maybe we will be there. I'm not sure, but yeah. And what about the negatively skewed distribution? Maybe our cognitive ability over time. Yeah, I usually feel that the ability of the memorizing something is decreasing now. Yeah, so different kinds of the cognitive ability over time is a really good example for the negatively skewed distribution. Then how about the uniform distribution? Maybe daily price, something specific, grocery or stuff, something like that. So usually in a day, those stuff does not change it. I mean, the price does not change it. So uniform is a really good example. And how about the J curve with a ceiling effect? Usually most of the cumulative something is J-shaped with ceiling effect. So cumulative annual rainfall has the J-shaped distributions. And what about the J-curve with a floor effect? Which one has gradually and continuously decreased? Maybe car price depreciation. We would like to have a uniform distribution for this variable, but unfortunately, yeah, this price continuously decrease. So those are really good example for each different kinds of the distributions. So this is the learning object for the video 2, and we learned a lot, including those different kinds of the definitions and different kinds of the examples. And if you see the module week 1 in the Canvas, you can see the SPSS instruction. And there are 2 different kinds of the videos. One is for the introduction for gaining remote access to SPSS, and the other one is the introduction of SPSS and frequency distribution SPSS video. For your future SPSS assignment, those two videos will be really big help for conducting those assignments. So I strongly recommend you to see those two videos. And that's all for this week lectures. If you have any question about the week 1 lectures, feel free to contact me through the discussion board in Canvas or email me. Then see you next week.